Now, let us try to find out the different type of problem statements you can have in your entire career there as a data science professional. And one of the most important and the most significant one for your job as well as for your interview perspective is the regression. In a much more simpler sense, we often call it like a linear regression, which is being either a single linear regression or multiple linear regression. When I say single regression, you have only one x variable. If it is multiple linear regression, we can have more than one x variable. In a much more simpler sense, I can put it more like regression is basically predicting the future values of a continuous dependent variable. So the keyword and the learning we have to have in our mind while talking about this entire conversation is that for regression we have first of all y being continuous, like sales, profit, income, revenue, all such variables which are having a numeric continuous values are being called as regression. Like I can give you a lot of examples for that. So I need to turn out to one of the spreadsheet for my easy conversation. So here you can see that if I am talking about predicting a value of a variable which is continuous in nature. So here y is continuous, like if you are required to predict the values of the sales or maybe the weather forecasting, how much rainfall it would be, or maybe you need to predict the prices of the stock, how much footfall will be there if you are going to open a retail mall, or if you are going to have a new flyover being built, how much traffic or the fall of the four-wheeler cars could be there, the mortality rate, how many seats a particular political party will win, how much vote percentage share a particular party will get, or maybe in a much more simple sense, you can say the prices of the houses or the cars in the second-hand market or the app-based businesses like Car Dekho, Carwala, Cars 24, all such are the automobile second-hand sale and purchase businesses, or maybe in the property businesses like housing.com, 99acre.com, or property.com. All these apps or the ventures are intended to estimate the prices, and all those prices are continuous in nature, right? You need to predict the values of the houses and the cars. You need to predict the price of the cars and the houses at the time of selling and purchasing the second-hand products, right? So, and those prices could be dependent on multiple variables, which model of the car is, how older the car is, which brand, because Maruti is obviously having the better resale value, correct? And is it a first hand or a second hand? Is it a single hand driven? Or the accidentally the condition of the tires? All each of these informations are nothing but one specific X variable, which is contributing in my prices as my continuous Y variable. So in all such examples, one thing is there that y is continuous, which you are predicting for. So all sort of these problem statements are required to be solved with one technique being called as regression, which could be single or multiple. When I say single, it's only one x variable. If it is more than one x variable, like the way I told you earlier, if you are going to predict the price of a second-hand car, you can have a lot of attributes which is contributing in the prices or impacting the prices, defining and deriving the prices, like which model of the car is. When I say model, like in which year it was manufactured or you purchased that, whether a car is a single hand driven or a multiple hand driven, is it an accidentally or not, which brand, like Maruti is having a different resale value as compared to Hyundai or Honda there in India, and a lot of other variables like color of the cars also contribute to some extent there in defining up prices, right? If you have some bright colors, maybe like green or pink, you will have a lesser prices in the second-hand market as compared to the regular colors like black color or a traditional white color. So in this case, when I say color, the model of the car, the brand of the car, the tire conditions, the accident or not, all these individual information is nothing but one single X variable. So you can have multiple X variables or you can have one single X variable. So one thing is now clear that you have to go through with all these things with one type of problem statements which comes under the tagline of regression, and the technique we use for regression is OLS, the ordinary least square method. What the OLS ordinary least square method is, we will be discussing that in detail in the upcoming conversation or in the modules. So hence one of the strong area what you need to have an expertise being there as a data science professional is the regression part, it is statistically very significant and comes as a major interview portion for all your job perspectives. This is what the regression is. Coming back to the original conversation, the second aspect in the data science world is classification. In case if the dependent variable is categorical in nature, so there is a keyword which can distinguish this classification with the previous keyword what we studied earlier in the form of regression. If you remember, in the regression, the dependent variable was continuous. Here we have the dependent variable as categorical. That means you are going to classify the data into n groups. That means those samples, data points are supposed to be grouped into two or more than two groups. Hence, we call it as a classification. In a much simpler sense, I can say that classification is nothing but classifying the data into two or more than two groups. And obviously, when I say groups, that means each of these values are classes. Just to have a better understanding with this entire conversation, let me come back to the spreadsheet, and here you get a chance to understand what the classification is all about. So, you can understand this classification as segregating the data points or the samples into two or more than two groups. Clearly, one can understand that here why the predicting variable for which you are going to predict is going to be categorically. That means it is having some classes, and those classes could be two or more than two. Like the examples are whether a patient is diabetic or not. So you have multiple records or the samples or the data points. You need to predict whether a particular data point or a entry is diabetic or not. That means two groups. Either you have to classify any particular object into this group or in this group. Similarly, if a patient is there in a hospital, whether he will survive or not. So you have a survival analysis as well. Or maybe whether a student is there in an academics examination, whether he will pass or not, whether customer will churn or not. If it is an email, so a lot of emails are there, so you need to classify whether that email is a spam email or not a spam email. If a credit card holder is there, whether he will default or not default. So all these examples are there which is having two classes, isn't it so? So if a data point is there, you have to put that either in this class, diabetic, or not a diabetic class. So either in this category or in that category. Hence, you are classifying that. Similarly, a lot of examples are there whether customer will purchase the product A or product B or product C. Or BJP will win the Lok Sabha election or not. The Team India will win this match or not. Fraud detection, whether a customer will be a fraudster or not, or he will default or not. So in all such similar cases, you are going to classify the data into two or more than two groups. But the important keyword and the learning here you have to have in place is that these groups are pre-labeled. When I say pre-labeled, that means these are pre-created groups. And you just need to put any of the data point in either the class A or class B. And this particular theme is called as classification. That means all such similar type of problem statements are to be solved with the approach of classification. And when I say classification, you have lot of algorithms there available statistically as well as in the machine learning based algorithms like logistics, where we have the binomial outcome to be considered. Or we do have the naive-Bayes theorem, decision tree, random forest, KNN, SVM, ANN, chat card, and so on and so forth. So a lot of different techniques and the algorithms are available which are more or less meant for only and only similar type of problem statements which comes under the umbrella of classification. Hence, so far we have studied that either you have to deal with the regression or classification.